everyone. My name is Jeremy Amogus, and today we are going to break down a C# program that generates a Sudoku puzzle. In this program, this is a 9 by 9 grid, and it uses numbers from 1 to 9 with no repeated numbers in each line horizontally and uh, vertically. And I will explain everything step by step. So let's get started. First, we start with the Sudoku generator. So class Sudoku generator. So a class in C# is like a blueprint for creating projects. It defines properties, data, and methods or an actions that objects of the class can use. So here we are creating a class that will handle the Sudoku generation logic. And now inside the class, we have to put protected int grid int 9 by 9. So the protected keyword means that the grid variable is accessible within the class, and any class that inherits from Sudoku generator. This is useful because we might want to create more specialized Sudoku classes later, and those subclasses can use the grid directly. And the int comma and grid, int is an array of integers, the 9 by 9. This indicates it's a 9 by 9 grid, which is the standard size for a Sudoku puzzle. We initialize the grid with zeros representing empty cells in the Sudoku puzzles. And then I'll put here private random rand equals new random. So here we create a random object that will help us randomize the numbers, and it's private because we only need it inside the Sudoku generator class. Next, we have to create a constructor. So I'm gonna put a note here for a summary. So this will help me so that I can figure out the program. A valid puzzle. And then public Sudoku generator. So what is constructor? Uh, in C#, constructor is a specialized method that runs automatically when you create a new instance or object of the class. So in this case, when we create a Sudoku generator object, the Sudoku generator open parenthesis and close parenthesis constructor is called, and it immediately calls the generate Sudoku. generate Sudoku. So this is immediately calls the generate Sudoku method to start the puzzle generation process. And the constructor is marked as public so that other classes or programs can create an object of Sudoku generator. And if it were private, no one outside the class would be able to create this object. And the next method, uh, we want to generate a fully solved Sudoku puzzle. So here, private void generate Sudoku. So here we use private for generate Sudoku because this method should only be called inside the Sudoku generator class. We don't want other parts of the program to call this method directly. And we are calling it fill grid. So this one, the fill grid is responsible for actually filling the grid with numbers using a technique called backtracking. Now, the next step is we have to create the fill grid method. So private ball fill grid. And then we will put here for loops int row equals row 9. So the for loops iterating over the grid, and then inside of it I will create another for loops. So we have two nested for loops here. The first one goes through each row, and the second one goes through each column of the grid. So essentially, this is iterating over every single cell in the grid. Next, we have to put if grid row and column equals 0. If grid row and column is, this means that we check if the current cell is empty by looking for a 0, and if it is, we need to fill it with a valid number. The next is we have to create a list of numbers from 1 to 9, and shuffle them to randomize the number. So list int numbers equals new list one, two, three, 4, 5, 6, 7, 8, 9. Um, this helps ensure the puzzle generations process is less predictable and no two puzzles will look the same. So we put here shuffle numbers. And we have to create a for each loop. The for each loop goes through each number in the shuffled list and tries it in the current cell number in numbers. So if the we have to create a statement below that if is valid, the row, column, and the number the grid, row, column, number, if fill grid. So this means that if the number is valid, we fill the cell and then recursively call fill grid to fill the next cell. And then below, return true. So we put here grid, row, column equals 0. Um, if places doesn't work and leads to an invalid state letter, uh, we resell we reset the cell to 0. It means 0 means empty and try the next number. This is a backtracking. We undo our choices and try again. And return false means we couldn't find the grid. And return true means we need to try. The return true means grid was successfully filled, and the return false means we couldn't fill the grid and we need to try again. So the next method is we have to check if the placing number is the placing number in a specific cell is valid. So we put here private ball is valid, int row, column, and the number. So the valid method, it will check if placing number in a specific cells violates the Sudoku rules. And we make sure the number is not already in the same row, not in the same column, and not in the same 3 by 3 block. So for int I equals 0, I 9, then if the grid row equals num grid equals the number, and then return false. So why we have to use the return false? Because if the number violates any of these rules, we immediately return false because placing that number in the cell is not allowed. And then we put here int start row equals row by 3, 3 by 3, start column 3 by 3. Oops. For int r equals 0, 3. And also the grid row I, this one, this checks if the number is already placed anywhere in the same row. If it finds the number, it returns false because the number cannot repeat in the same row. And this one, this checks if the number is already placed anywhere in the same column. Call is column. If it finds the number, it returns false because the number cannot repeat in the same column. This is important because these loops ensures that no duplicate numbers exist in the same row or column, which are the key roles of Sudoku. And this means that this is calculating the top left corner of the 3 by 3 subgrid. And the each 3 by 3 block in Sudoku needs to be checked to make sure the number doesn't already appear in that block. The row by 3 by 3, this calculates the starting row index of the 3 by 3 subgrid. The division by 3 finds the black row groups of 3. So row division of 3. and it groups of 3 and multiplying them by 3, it gives the actual starting row index for that block. And the column division by 3, this calculates the starting column index of the 3 by 3 subgrid in the same way. And the next, uh, for int c equals 0, c, so the first for loop r, integer r, iterates through the rows of the 3 by 3 block. And the second for loop, which is the c, iterates through the columns of the 3 by 3 block. And next, if grid start row or start call plus c equals num, return false, and here return true. This means that this checks each cell in the 3 by 3 block by calculating the position of each cell relative to the starting row, the start row, and the start column. If it finds that the number is already placed in any cell of that block, it returns false because the number cannot repeat within the same 3 by 3 block. This is important because this nested loops ensures that no numbers repeats within any of the 3 by 3 block, which is another rule of Sudoku. And I put here the return true. It means if none of the previous checks return false, this line will execute and the method will return true, indicating that placing the number at that specified position is valid. The next method is we have to create the shuffle method. So I will put here shuffles to randomize the Sudoku generation. Shuffling is important to randomize the order of numbers we try to place into the grid. It makes the puzzle generation unpredictable and less likely to follow a repetitive pattern. So shuffle list int numbers. So again, the I put private here because it can, meaning it can only be accessed within the class, belongs to the Sudoku generator class, and no other class or outside code can directly call this method. And the void, it is a return type, meaning it doesn't return any value. It simply performs an action shuffling the list. And this one, this is the parameter the method takes. It's a list of integers which represents the numbers that will be shuffled. And then below, we have to put the So we have to put the for loop. This loop is used to iterate through the list of numbers but reverse in order. Integer I equals numbers that count 1, I equals 0, I. So the numbers count minus 1. This starts the loop at the last index of the list numbers. It gives the index of the last element in the list. And the I lesser than 0, the loops run until I is greater than 0, which means it will stop when I reaches 1, since we're looping backwards. And this one, the loop decrements the I by 1 after each iteration, effectively moving from the end of the list towards the beginning. And by looping backwards like this, we're ensuring that the shuffling process works efficiently and doesn't require checking the entire list more than necessary. And then here, this is called the random number generations. So int equals ran next I plus 1 numbers I numbers j equals numbers j numbers I. So this one, it means the functions generates a random number by passing the I plus 1 as the argument, and you get a number between 0 and I inclusive. So j is a random index that is less than or equal to I, and y, it's I plus 1, since the random next generates a random number between 0 and the number we provide, and the I plus 1 ensures that the j can be any number from 0 up to I. And then here, this is what we call the swapping elements. This is the key part of the shuffling process. It swaps elements at the position of I and j in the numbers list. And this one, this is a tuple where the elements at position I and j are referenced. And the second one, the j and I, this is the swap version of those elements. This is important because the swapping step ensures that the numbers are randomized. Every time a number is swapped, it potentially changes the order of the list, creating a new random arrangement. And the next method is the to display the Sudoku in the console. So here I'll just put a note, display the Sudoku puzzle formatted 9 by 9 grid. So I'll use the method public so that it can be accessed by any other call that calls including it. Virtual void display Sudoku. because I want the Sudoku grid to be displayed to the user, and therefore it should be publicly accessible. And I choose mar the virtual method, which means the other classes can override this method if we want to provide a different way of displaying the Sudoku. And the void, meaning it doesn't return any value. The job is to print the Sudoku grid to the console. And then inside the class, I will put here for int row equals 0, row 9, row plus plus. For the for loop, this loop iterates over the row of the Sudoku grid. The grid has 9, 0, since it's a 9 by 9 grid. So the loops run from 0 to row 8, lesser than 9. So to row 8. The purpose of these loops is to go through each row of the grid one by one. And inside the for loop, uh, I will put here if the row 0 and row is not equal to 0, console write line. So this is the conditional statement. This checks if the current row is a multiple of 3, and it ensures that it is not the first row, which is not equal to 0. And the row, this checks if the row is divisible by 3. In Sudoku puzzle, the grid is made up of 3 by 3 subgrids. And the console write line, I put the blank here because, or the dash, if the condition is true, it prints a line of dashes to the console. This line will separately the 3 by 3 subgrids visually, and you will see that later. And here, uh, we are going to put the inner for loop. So I'll put here int equals 0, column 9, column plus plus. So this loop iterates over each column in the current row, just like the rows, the grid has 9 columns, so it runs from column 0 to column equals 8. This loop handles the printing of the number in each column for the current row. And inside the for loop, we create a class 0 and column not equal to 0, console write. We put the pipeline and then console dot right, grid, row dash col plus end of the statement. So this is the conditional statements. This checks if the current column is multiple of 3, then this checks it is similar to the rows you want to separate the column for of each 3 by 3 subgrid with vertical lines. And the console, this is a vertical bar. If the condition is true, it prints a vertical bar followed by a space to separate the subgrids visually. And this means this line, the console.write, this line, it prints the value of the current cell in the grid at position, the row and the column. And the numbers in the grid are printed sequentially row by row. And this one here, the plus and the 2 apostrophe, it adds spaces after the number for better formatting, making sure the numbers are spaced out properly. And I will put the console write line here. Sorry, wrong spelling. Console write line here. After each row has been printed, this console write line statements moves the cursor to the next line. So the next row of numbers will be printed on a new line. This ensures that the grid appears in a properly formatted 9 by 9 grid layout. And the last method, we are making uh, inheritance from Sudoku generator in Sudoku game. So I will put here Sudoku game, Sudoku generator, and inside of it, so this is this means that the the Sudoku game inherits from Sudoku generator, which means it has all the features of Sudoku generator like the grid and methods, but can also customize or add new features. We override display Sudoku to add header before showing the grid. The inheritance, it allows the Sudoku game class to build upon the functionality of Sudoku generator and add or change behavior when needed. And inside the class, we will put here public Sudoku game base. So this is the constructor of for the Sudoku class. Constructor is a special method that is called when an instance of the class is created. It's used to initialize the object states. And the public Sudoku base, open and close parentheses, and with the curly braces, the constructors calls the base class constructor using base. And the base is a keyword is used to call the constructor for the parent class Sudoku generator. In this case, the Sudoku generator constructor is called to ensure the Sudoku grid is initialized properly, since the Sudoku generator constructor generates valid Sudoku grid when called. So calling base ensures that the grid is set up for the Sudoku game instance. And the public, uh, as what discussed earlier, this means it can be accessed from outside the class. So this is required so that when we create an instance of the Sudoku game class, the constructor is called automatically. So below, we have to create a display to add the header. And I will just put documentation here, display method to add a header, public override void. Display the Sudoku. So this means that it defines the method in the Sudoku game. And the override keyword tells the C# compiler that we are providing a new implementation of the display Sudoku method. And by that, it will replace the implementation in the base class, the Sudoku generator. And inside, we we will create a console display, console write line, generated Sudoku puzzle, and base dot display Sudoku. So this means that before displaying the grid, this line prints the header generated Sudoku puzzle, and this will show in the console. And the slash n at the beginning and end of the string, this one, there is a blank line before and after the header to make it look neat and separate from the grid. And the base display Sudoku, this means that it's a method from the base class, the Sudoku generator. And by using base, we are invoking the original method from Sudoku generator to display the actual grid from after printing the custom header. This allows the Sudoku game class to reuse the display Sudoku logic from the Sudoku generator class while adding custom functionality. And why we have to use the base here, the base keyword is used here to call the inherited method from the base class. So the functionality of displaying the grid remains the same, but we are simply enhancing it with a custom message at the beginning. And the last part is we have to create a class program. Uh, the program class is the entry point of the C# application. This is where the program starts executing in a C# application. And here, uh, we put the static void main. Main method is the first method that runs when we start the program, and the program class typically contains the main method, which is why it's named program here. And inside the main program, We will put here Sudoku game, Sudoku game, open close parenthesis, and the game that display Sudoku. So here, this one, we are declaring a variable game of type Sudoku game. This variable will hold an instance object of the Sudoku game class. And the new Sudoku game, this is creating a new instance of the Sudoku game class. By calling the new Sudoku game, we are invoking the constructor of the Sudoku game class, as explained earlier. This constructor initializes the grid and generates a valid Sudoku puzzle. And the instance game now has all the properties and methods of the Sudoku game class, since Sudoku game inherits from the Sudoku generator. The object also has access to the logic in the Sudoku generator, like the grid generation and validation. And this one here, the game that displays Sudoku. Now that we have an instance of the Sudoku game class stored in the game variable, we can call the display Sudoku method on this object. The display Sudoku method is the one that prints the Sudoku puzzle to the console, since the Sudoku game overrides the display Sudoku method. This is the version that gets called here is the overridden version in Sudoku game, which first prints the header, the generated Sudoku puzzle, and then calls the base class method to display the grid. All right, I think that's all for today, and I was able to create the program of the Sudoku game. Now let's try and see if it will generate the Sudoku puzzles randomly by 3 by 3 grid. So here's the result or the output, and it's 3 by 3 and 1 to 9 from here, vertical and horizontal. And you don't see any uh, numbers, the same numbers that match. They are random. There is no duplicate. That's all for today, and thank you for watching.